All right. So we are going to talk about the last lesson of this chapter, okay, of this module, Docker. So we have so far used single stage build, okay? What is build? So build is the process where we take the code of the application and we compile them and we package them inside a special I think you can say kind of image, okay, which you provide the name and you package the dependencies, the libraries, the version, then the application code, okay. So this process of building the application, okay, has multiple like commands. You take the code, then you set environment variable, you install some dependencies, and all of these things that you do, they are part of the Docker file. Okay. For these Docker files, what we have seen so far, they are single stage. So you have one stage, you write the code, you follow the commands and everything, and you finish the build process, right? So this is what we have typically done so far. This is called the single stage build. Okay. So what I mean by that? So I mean by that this. Okay. So for example, this is what I mean. Okay. This is your single stage build. So you have taken the code base, like the base image. On top of that, you have defined certain arguments, environment variable, you have declared the working directory, then you copied the code and everything, then you install the dependencies, then you started the application, right? So this is why we call it single stage, because we do all of this in just one go, in one portion, okay? This is called the single stage build, okay? In the multi-stage build, what we do is we have multiple steps, okay? We have the previous step, and that step gives some output which is used by the next step. So for example, if you see, this is from stage one, okay? This stage will produce some artifact, some output. Stage two will just take that output, okay? It will directly use it. On top of that, there can be third stage as well, and that will use the output from the previous stage, okay? This is called the multi-stage. But why do we need multi-stage? Because single stage builds have certain limitations. Okay. What are these limitations? So the first one is the build environment. Okay. So normally what happens is that whenever we are doing single stage build, okay, we depend on the base image that we have selected. Okay. So this is the base image. For example, this is node 22 that we are going to use in this. So once you press say node 22, then you depend on this particular base image to provide all the dependencies. Okay. And like dependencies and tools and everything. Sometimes it will be hard for you to get other packages and dependencies which can hamper the development. Then is the image size. This is very, very important. So normally what happens is whenever you build an application, the base image determines a lot of fact, like how big the base image is. On top of that, you keep adding the changes and dependencies. And because of that, the image size, the final output image size will keep becoming larger and larger, right? And if you do that, then this will unnecessarily bloat the application size, right? Because the base image itself was very large. Okay. And this is the reason that single stage build have large size images. Okay. Third one is called reusability. Okay. So if you build by application with multi-stage build, okay, then you can use the previous build environment. Okay. This is called something concept of layer cache. Okay. So this brings us to discuss a very important concept in Docker, and that is called Docker layers. Okay. Does anyone know about it? What is layers?
Is it is it a way of ordering the process?
Mm, not really. Okay. So no problem. Well, let's discuss about it. Okay. So this is a very important concept in Docker. So what happens is that Docker, if you even go and see any image, okay. So for example, if I go to this particular user, okay, and let's have a look on any particular image, okay. So let's say this image is, let's say this one, okay. If you go to this image, okay, you will see, if you click on any of this, you will see that these are the multiple commands which has been used to build this image, right? And these images will generally produce a SHA key, okay, so that we know that this image is correct or not. And let me see if I have some uh, history commands or not. I don't have it since, but let's say I go out and I don't have that log otherwise. But if you remember, whenever you write Docker build, you have some of the cache, some Shaki you keep seeing, right? This is something like this. A big number shows. Let me probably find something which can have this. So let's go to document page, okay, and let's say so. Let's say I do Docker build -t, okay, dojo now dot, okay, Docker build, oh, Docker build, right? If you see what is this trying to do, it is saying, see, multiple layers it is building, cache 1, cache 2. Then whenever it performs a particular build, okay, it writes that okay, with a particular SHA key, okay. And this is how you have the multiple layers. So everything happens layer by layer in Docker, okay. So this is the kind of the base image, okay. And if you, for example, if you see here Docker images, if you go, you will see this image was built 2 years ago. Is that true? I was running just few moments ago. This was built 7 weeks ago. No, I was running it hardly like half an hour ago. So I built 2 weeks ago. Why does it so like this? Can someone tell me? Why does it so old, like 2 years ago, 7 weeks ago? 2 years ago, I didn't have this laptop even.
Is it because you're pulling it
Mm-hmm.
from a different source?
Mm-hmm. Very good. So this image is actually coming from somewhere else. So even though I use this particular image, okay, but this image has no changes, right? So this will show no effect. So for example, if you take an image, okay, and if you just print hello world, it will show you this image was created very long ago. Reason? You did not make any changes on the layers of the Docker. So all of these commands that you have, okay, all these instructions, they all build a layer over layer, layer over layer. Okay. For example, another good question is this. Why do you think, why are we copying it 2 times? This will also do the job, right? Copy everything. Any idea why do we do this?
So you're asking, why did you have copy twice?
Mm-hmm.
Is it because of the different layers?
Mm-hmm. Mm-hmm. Yeah, definitely. So basically, can you complete your answer, Nika? You are definitely in the right direction.
Mm, if you're saying that you have all these layers Maybe because each time you're building on top of the other, you want to make sure it's getting everything it needs so you can build more. But I'm not sure.
Okay. Okay. So basically what happens is every time that you make a copy, it makes a new layer on top of the previous layer, any instruction that you give. Okay. So what happens is that we are working on this code. Okay. We are copying this code from local machine inside the container. Okay. So whenever you do this command, it makes a new layer. But what happens? Normally, we do not make changes on the package.json file, correct? We generally make changes on the application code only, isn't it? So we want to take the advantage of Docker layer caching that, you know what, first copy this. So if there is no changes in package.json, it will not perform that step again. It will directly take that step from somewhere in cache. Okay, you see, cache. So it is directly using the cache, internal load build context, transferring the context. It has directly used it. It did not create it again. Okay, so that is the benefit of using layer cache. So if you are working on this application, if you just make changes inside the code, this will have no effect. This will not change. So when you build the next time, at least these many steps will be safe. Okay, and now you copy the code and then you install the dependencies and yeah, you will continue.
Is that because, so if you just had the single copy dot space dot, because it's attached and you can't separate the packages.json from the rest of the code, then if you make a single change to any of the code, you have to then run package.json again. It has to read.
Exactly. So if you,
Okay.
yeah, if you just have this one, you will not get the benefit of this layer cache, right? Because even if there is a small change in this code, you will be copying this code as well, which is not required, right? And in fact, you know, this code will make more sense if I do this, so that it will not run npm install at all again. Okay, this code will make more sense this way, so that if till there is no change in the package.json, it will not run any of the system. It will go and do directly this. Getting the point?
Yes, that was very helpful.
See here. So what happens is every time you are performing this, okay, it is building, and I wonder why I'm not finding a good image. Yes. Oh yeah, this is a very good image. Yeah, this is what I generally use to explain. This is your kernel, okay? On top of this is your boots file system. Forget it. This is your base image. On top of this base image, you are adding every command and building every new layer. Okay. The moment you use layer cache, this layer will remain as it is. And what will Docker do? It will start building on top of that layer. But let's say you want to build from here, but you have no changes in the previous layer, but you are still not using layer cache. You are still copying the code. What will happen? You are unnecessarily performing all these steps one by one while there was no change in that code. There was no change in that step. Make sense? Till I do not make changes in the code application, I don't need to actually and do npm install. Do you do npm install always in React? You don't do, right? You do npm install once, then you keep developing, you get a new library, then you do npm install. Can someone confirm me? I'm not the React expert.
We're not React experts either.
No, but that
but you
sounds right.
definitely much will know.
Yes,
In
though.
front of you, you are the expert, okay? In front of me, at least.
Okay, I'll give you that.
Uh,
So it's not wrong for me to think of Dockerfile like a giant layer cake.
yes, it is like
Okay.
layers. You have is kind of, you're like sandwich or probably burger where you have layers on top of this, on top of this, right? Kind of.
I'm a digital artist on the side, and it reminds me of the art program I use with different layers. And in the end, I collapse them all into one item when I'm done. But this reminds me of that as well as Nika's layer cake.
Yeah, I was thinking the same thing, Cass, when you're doing stuff with Adobe as an example.
Oh
Yep.
yeah, in Photoshop you have the concept of layers, right?
Yes. And
Exactly.
Autodesk Sketchbook you do as
Oh,
well.
100%, right? You build on top of the layers, right? So definitely, till you don't need, you don't change the base layer, right? You only change the top layers where you want to make changes, right? Till you don't need. So that's the same thing I want to talk about here. That till you don't make changes in this code, in this particular file, you don't need to run the npm install back again. Okay, this is how React works. Okay, but in this particular case, I'm still like on fence. I'm still working on this to figure out both work or not because it has been a while. I have worked on React projects. Okay, so I will reconfirm this, but you should get the overall concept, which I mean to say, tell you that use the layer cache. Okay, so this is the concept of layers in Docker, that you take a base image, you build on top of this multiple layers, and you try to take the advantage of layer caching till you don't need to rebuild that particular step. Just use it. Just don't make changes on that layer. Okay. So we will be taking the advantage of doing that whenever there is, for example, let's say this was like Python code. You will actually first copy requirements.txt. Okay. Then you do whatever pip install. Okay. And then you will do,
Install is not spelled correctly.
oh, yes. Yeah. Thank you. You got the point? I am first getting the dependencies, then I will get the code. Did you understand this? This is one of the least understood and appreciated concept of Docker. So yeah, but this is very tricky, very good interview question that optimize this Docker file. People will say, okay, optimize this Docker file. What will you do? You will do many things. You will change the base image, you will change the layer caching, you will change, make this single stage to multi-stage. Okay. So these are some of the benefits of Docker single stage and multi-stage build. Then you have the security also. Okay. So what happens is that sometimes when you want to build the code, you want to use the build packages. Build packages are generally not production grade. They may have some bugs and issues. So you only need to use the components which you really need for production. You leave out all the unnecessary parts of the application. Okay. So this also increases security. And as I told you, it uses the concept of layer caching and all. So multi-stage build is also time saving. It takes less time to build if you are doing this multiple times. Any questions? Okay. So we will now go ahead and work on this lesson on Docker multi-stage build. Okay. In today's lesson, we will be taking an example of a Node.js application. Okay. We know what is Node.js. Okay. What is Node.js? Can someone tell me? How does
Is
Node?
it the JavaScript runtime?
Yes, it's a JavaScript runtime. Okay. It uses a Chrome virtual DOM. I know, not virtual DOM. I forgot. It's a technical word that is used for it. Yeah, Chrome V8. Okay, JavaScript runtime. Yeah. Okay, so they have used front end. Okay, JavaScript are generally popular for front end development, right? They have used the same for back end development using Node.js. Okay, so what we do here is you will have multi stages. You will have first stage which will work as the base image. Okay, then you will have the next stage which will work as probably, let's say, linter. It will lint the code. Then you will have the next stage. From linter you will take the code and you will build the code. Finally you will take the code and you will run the code. Okay, so this is what we are going to do in the next lesson. Okay, in the next lab. So everyone, please open your terminal. Okay, and so we will go ahead. Okay, and okay, opens the window, right? I don't know. It doesn't open. Anyway, okay. So cd docker multi-stage. Okay, and now we will work in this place. Okay, so what we are going to do is we will take a particular code. Okay, and we'll first do a single stage build and then we will do the multi-stage build. Okay, we will take a very simple example and we will try to understand what is the difference between them, what is the size difference, what is the efficiency difference that we get because of using the multi-stage build. Okay, so this is a very simple Node.js Express application, the simplest Node.js application possible. Okay, so everyone, please go ahead and create this file. Okay, so here, okay, hello. Okay, and here I am going to create a file app.js. Okay, I'll copy this and put here. This is going to be my case code, and this I will go ahead and create package.json file. Okay, so this is my package.json. I'll copy this. Okay, so let's do the single stage build for it. Okay, so this is the single stage build code, a Docker file for it. Okay, so let's write a Docker file for it. Okay, in this Docker file, we will first select from node 14. Okay, so we are using node 14. Okay, then we are setting the working directory. Okay, so we are setting usr src app. You can set any working directory, that is not a problem. Getting the point? You can set anything. Only thing is you have to remember and you have to reference the file coming from that path only. And then we'll copy this. Okay. You see, we are taking the benefit of layer caching here. Why are we doing copy 2 times? Do you see the use now? Anyone who understood this?
So we don't have to copy all the other things that we only need to run the one time.
Exactly. You beautifully explained it. Okay. So you will only copy the thing that you really need. Then we'll do the final copy. Okay. Then we are going to do the final thing, that is exposing the port 3000 to run the application. Okay. This code is running on port 3000. Okay. So this is the single stage build that we are doing. Okay. So let's do the build. So let's change. Okay, no problem. I will change this name Docker file to single stage. Okay. So we know that this is a single stage build. Okay. So let's do the, any questions so far? Any doubt?
No, I think we're following.
Okay. Let me see chat. Just give me a second. I see something. Oh yeah, yeah. Punch Man. It's the Punch Man, right? He's the same guy like who gives one punch and the person dies, kind of. Is that right?
Yes, I was just
Yeah.
introduced to him. Somebody suggested it. I was telling Tristan my favorite line so far. Well, I only saw one episode. I trained so hard, my hair fell out. I was like, what? It's funny.
I know this guy. This was the first anime I had watched, I believe. Okay, so just write it docker build -t and let's give it a node single. Okay, so I will know this is Node.js single stage application. I'll have to give -f because Docker file name has been changed and the Docker file is the same bind path. You can see it is pulling, you see, it is using a lot of cache. Okay, that's it. It has built the image. Okay. How do we run it? So how can we run it? We can write docker run minus name. Okay, node single. Okay. If there is one more flag, you can give minus rm. What happens is the moment you stop the container, it will automatically get deleted. Right? Sometimes it happens, right? If you want to run it again, it will throw you container already exists. So if you give -rm, it will automatically get deleted. Okay. Then -p, and let's run it on, let's say 9876:3000. Right? This is the 3000 port we have exposed. And then we give, what was the image name we gave? Image name is node single. Right? Oh, port 976 is already allotted. So my favorite port has been taken. So let's give it probably 8080. Okay. You can see application is running on port 3000, but we will be accessing this on port 8080. And you see, hello world, right? The very basic code application we have. Okay. The next step, what we will be doing is, okay. Any question on this? I believe we have done this, right? So there should be no doubt on this. Okay. I will now continue and I will write Docker file. Okay. Multi-stage. You spell it like multi or multi? What is this more common?
I think either way is fine. Honestly, we'll still know.
Okay. Okay. Sure. Okay, so now we are going to do the multi-stage build. Okay, so here we have two stages. Okay, why do we call it two stages? Because we have broken down the whole Docker file in two parts. How did we break it? So we have taken first part as the builder part. Its job will be only to build the application. Okay, it will take the working directory, it will copy the code, it will build the code. Okay, it will copy the code. Okay, then is the next stage. In this stage, we will be copying this code. Okay, src okay, from here, from builder, copy minus minus dash dash from is equal to builder. We are taking from this step, copy what? From this path usrsrc app to the current working directory usrsrc app. Did you understand this? How are we trying to link? This command links this to the previous one. Okay, and then as usual you will do node app.js and you can see the difference. So let's do the multi-stage build here. Okay, and let's build this. So this is running on, let's say, port 8080. Okay, let's keep it running and let's build it again. I will build it with, okay, I will give it okay, and we are using multi-build, and you can see it has used so much cache, so much cache it has used. Okay, and now we will use the same command to run it. And I believe everyone knows how to use this by now, right? So we have multi-stage build, and we will, this port has been taken, right? 8080, so we'll run it on 8081. You can see this is the same application is now running on port 8081. Oh, this was coming from cache. See, layer cache. Everywhere is caching. So we have the same application running, okay, on the same port, okay. Internal port 3000, external is whatever you give. But the benefit you will see here, okay, benefit is here. So if you see here, the size here, okay, is very different. You see the size difference? It is significantly smaller, isn't it? Think about the impact of it. Okay, this application is approximately, okay, is approximately 750. Okay, let's say approximately 750 MB. It is smaller. Okay, 750 MB is a lot, like, okay, 750 MB is a lot. Let's say you have 100 such containers running, servers running. 750 into 100, okay, is how much? Lot, right? 750 MB is almost like 1 gigs. And if you multiply that with 100, like 100 into 100, right? Sorry, 1 gigs into 100, right? Almost like 10% of a TB, right? That's like a big number, right? So for this reason, we will go for multi-stage build so that we make the image smaller. This image will be more secure as well because it has only the limited dependencies. No unnecessary things are coming in this. We are only using the minimal code that is required. This. So why is the difference here? Because we are using here Node Alpine. Here we are using Node 14. This brings such a drastic difference when we are copying the application code which we just need, which we really need. Okay, otherwise we will not be using anything else. Any question on this?
So really what happens in stage one is we're just getting the dependencies from that first node 14. And then from there in stage two, we're trimming the fat using Alpine, but keeping the dependencies from the first one, from the build.
Percent. So what we did essentially is we have trimmed down all the unnecessary things. This one we need here because Alpine has nothing, right? Alpine has no NPM. So you cannot use an NPM in Alpine. NPM has, Alpine has everything removed. Very, very basic thing. Even the package manager is not inside Alpine. Right? So we will break down the step in two parts, building one and using it. Okay, any questions? Can you think of scenarios where this could be very helpful? Some more examples, everyone? Oh, developers, you're coming from development experience.
I guess in the example you had where you're making hundreds of the same, but instead of hundreds of the same, if you had another compose of several ones, you can definitely reduce each and every single container in the compose.
100%.
So you can save a lot of space.
Lot of space and lot of network bandwidth and lot of compute, right? Processing power you will save. So significant saving you can do. Definitely. Think of
I
again.
guess, yeah, I guess another example is if you're trying to, because when we use services on the cloud, if we can reduce the space of the containers themselves, then we can use a smaller containers to reduce the cost on the cloud.
Exactly. Instead of T2 large, you just need T2 micro. It will do the same job. Yeah, definitely. Give me some examples from platforms, frameworks where it will be useful. Some framework examples. These are the end benefits. Which all use cases will you be applying this? Can you think of Java? Some examples from Java, everyone.
I couldn't say that we could, just because we haven't really messed around with Java.
Oh, okay. Okay, no worries. Let me kind of show you quickly. So, okay. So normally what happens is this is your Java application. Okay. So this is how the Java applications run. Okay. So in Java applications, okay, you have the core part is Java virtual machine. Okay. When Java came, it was revolutionizing in software industry. Okay. You should read the history of Java, why Java is still so powerful in enterprise applications. Okay. The most powerful framework and most used framework in industry still is Java. Okay. especially enterprises like large organizations, okay, established organizations. So you have the Java virtual machine, which helps you to run your application code as the bytecode, which can be put anywhere in the different machines. On top of Java, then you have the Java runtime environment. This is the environment which will run the application, okay? And this is the JDK. This is the Java Development Kit. This has all the development tools. It has Java C, then you have JHeap, JConsole, a lot of different tools are there. During development, you need this, but during runtime, you don't need this. So what will you do? Using first stage, you will build the application. In the next stage, you will just use the application with a runtime environment, JRE. Because for running, you don't need development kit, right? But for development, you need that JDK. So this is another good example of using multi-stage build to save space in Java applications. Some more examples? Can someone think of? Something from React. What do you think? React applications. How do you deploy React applications? Tell me 10 ways how you can deploy React applications. 10 ways. I'm telling randomly. I think there should be at least 5, 6 good ways.
Maybe something with stripping out the actual framework for the front end side and using Nginx in stage 2.
Perfect answer, right? Exactly. So you don't need the development environment when you are using Java applications. What you do is you build the code and you serve that React application using the Nginx. Can you remember it now? You must have used npm run build, right? Exactly. So npm run build used to does the same thing, right? It also, so normal React application development environment has a lot of things like it has transpiler, which itself is very heavy, right? What is transpiler?
That's the like if you have TypeScript,
Mm-hmm.
then it compiles and also translates at the same time.
Mm-hmm. Yeah. Yeah. Right. So you write the code in your more user-friendly manner, right? Using React, using TypeScript, okay? But you deploy the application in the native JavaScript, right? So for that, you have a lot of compilers, transpilers, and there are a lot of like, there is something called watchers, right? Have you used watchers in React? Right? They by default come. Yes?
No, that doesn't sound familiar.
Okay. No
What
worry.
are watchers?
So watchers are like, so when your applications become very, very heavy, very, very large, then watchers is kind of another kind of extension, another tool, which will help you to focus, which will make the development faster, that it will only watch the changes which are happening on some particular files and components. You will not watch the whole application. So it does not restart every time complete files. Okay. So it will make the development faster. So when you make the changes, it will immediately get reflected on your front end. Okay. So there are many tools like this. Okay. But anyway, we'll focus back that. So the next demo we have is about the same thing. How can we use multi-stage build for React.js applications? Okay. So we will go for, I know that we are an hour, so we'll go for 10 minutes break. Returning, we'll start with Node.js application. Sorry, React.js application. All right, let me know if you're here so we can start. All right, I believe I can start. Okay. All right, so as we have discussed earlier, okay, we have discussed that layer caching can be very helpful to save space, to save the processing power, and anything which is not really essential, it can be uh, eliminated using multi-stage. Okay, so in this next step example, we are going to have a look on this application, sample create React app. Okay, so we will be building create React app using single stage and then multi-stage, and then we'll again compare. Okay, and you will also see how to build a React app if you have to deploy using Docker, which is generally not done, but if at all, let's say if you do. So if you have an npx, okay, a node package manager, then you can use directly that. Otherwise, you can use this repo as well. This is the repo create React app. Okay, so this is generally the go-to repo, okay, for people who are working on React application. Okay. Now I will copy this. So I will write git clone. Please get this code base, git clone. Once you have cloned this, okay, we'll go inside, okay, and we will do the first part, that is the single stage build. Okay, so there is something that you have to be careful about here. Okay, that is uh, that this particular step, it seems, is only needed for Mac machines. Okay, the ARM64 machines. If you're not on Mac machine, if you're on Intel probably, it seems you will not need this. Okay, but again, like, I'm not very sure about this. Okay, so for now what I will do is I will go with this code only. Okay, because as things keep changing, some of the libraries get up support for ARM64, some don't, so sometimes you have to do this, but still I have tagged it, but probably you can just go ahead and use it as it is. Okay. So let's understand this code, and let's try to build this. So I will create this as a single stage. Okay, so here outside somewhere create a file, docker single stage build. Okay, if you create docker single stage, and this is the code that we have. What is this code doing? So this code will use node 22 as the base image. Then it will set the working directory as /app. Then it will copy the package JSON as we discussed earlier. Then it will copy the rest of the code. Then it will install this. Okay, it will set the environment. Okay, now I am not sure what this is. Okay, but this is what I have used earlier when I was facing this issue. If you don't use this, it will throw you error, okay, every time. So it seems that it is needed on all Mac machines, okay, ARM64 machines. So for this reason, I think I have kept it. I think you can just go ahead and keep it as it is. So what is this repo? I believe that this repo is yeah, this is some dependency used for this application. If you don't use, you can try without it. If it works, that is good. But at least on my Mac machine, doesn't work without it. Okay, so I will just go ahead, and then it is npm install, and then we'll just do npm start. Okay, I believe everyone is okay with this. Any questions? Okay, so this is the Docker single stage file that we have, and now we will go ahead and build this image. Okay, So we will go ahead and create, okay, like Docker build -t. Let's give it React single stage build. Okay. Oh, we have changed the image name, Docker file name, so we'll have to give it. Ideally, I believe this copy should run even after this, but I'm not 100% sure right now because it seems that this environment true is important to go inside the code before this install start. This is started. It seems this should work. I'm not sure about this one because this is multi-stage. I'm not very sure. So on safer side, I'm copying earlier. If time permits, we'll experiment with keeping it later. But technically, theoretically, it should work even that, unless this works a different way. Okay, so let's okay, so it is performing, it is installing this. It seems for some reason this library is very large or something. And I was informed, Yams, that your machine doesn't have enough, like the memory or space to run Docker. So, in my last chat with Edwin, I suggested that, you can just use the EC2 server directly. You do SSH, install Docker in this, and directly use it.
Yeah, I did try that out, and it did work. It was much better.
Okay, yeah, that's very good, right? So if you can do something on your machine, do it on server.
Quick question, Jans. Were you able to get your Docker Hub working without, I mean, your Docker without working without having Docker Hub like being open?
On my own system, without
Yeah.
having, no, it's still the same.
Oh, even if you enable WSO2 in Ubuntu?
So when I open up my Docker desktop, it goes straight into this. It's stuck on a loading, so I can't even change the settings.
Oh, okay, damn. All right.
Hmm. Okay, so yeah, I think you can keep using server for the very least, otherwise. Okay, so we have gotten this image, and if you run this, port 3000 has been given already. So let me see what is running. I will stop that. What is running? 3000. This is running. Yes. Okay. So this application is running on port 3000. Okay. So if I open now right now on port 3000, it should run the create React app application. Okay. Simple, right? What did we do here? So we are using single stage build. How does it work? It uses node 22. It copies the JSON, then it copies the code to get the advantage of layer cache. And after that, we will just do installation. We'll ideally run just pip install. In this case, okay, yeah, in this case, you can just use npm install after doing this, and then do npm start. Okay, and this will start the application. Simple, right? So this is the single stage build. Okay. So you can see this is running here. So I can go ahead and stop it now so that it becomes free. So I will go ahead and stop this. Okay. So yeah, this will get stopped. Now let's do the multi-stage build. Any question? Okay, let's do the multi-stage. So we did single stage here. Let's do the multi-stage build here. Okay. In this multi-stage build, okay, we will break this into two parts. Okay. We will use the initial step as it is. Okay. We are setting the working directory as app. We have the copy the package JSON, then again copy the code and everything. We have run npm install. Then the next stage comes, that is the npm run build. Okay, because that was development environment, and this we are using as the application environment, as the runtime environment. So we have the run build, and then we use set nginx as final. This is the final stage, stage 2. This was stage 1. This is stage 2. And here we are using nginx, which Troy suggested that you can just use nginx. So we are going to use nginx. And here from build, this is the build. We will copy the code from /app build folder and put it directly inside nginx folder. Okay. We'll expose port 80 and we will write nginx -g daemon of. This is generally used in Docker, okay, so that this automatically does not restart. Okay, so this is just a flag which is used. Okay, so you can go ahead and read about it. What is nginx daemon of? Okay. So this is generally used in Docker file so that daemon in the, okay, so for nginx to stay in the foreground. Okay, and Docker can track it properly. So this is generally used in, it's a custom cmd command. Okay, so you can go and read about it. Daemon off is generally used for example, in this like supervisor or anything. If you're going to use, it is also used by Docker to keep the track, is my container running or not? Okay, sorry, is my process running or not? That is the whole purpose of it. Sounds good, everyone? Any question? We will just go ahead and use the same code and let's build this. Okay, we will use this command docker build react single. I'll just make it multi to save time. Okay, so okay, I have to give the path as well. So what is the file name? We have docker. And now we are, and you can see it, I use so much layer cache to directly doing the npm install. You see, ARM64. Definitely, I must have missed it. Yeah, yeah. This is, oh yeah, I must have this. Otherwise, it will fail. Okay. So I will have to put it just in front of this. Okay. Because this is, otherwise, you will get this error. Okay. This is the error you will get, that Chromium binary is not available for ARM64. If you search this is the error you will get. Okay, Chromium binary is not available. And this is where people recommend that you just add this. Okay. So let me build this again. You can see it will take so much time sometimes because definitely React is not very fast in building. Okay. But after that, it will become very lightweight. But okay, we have done npm install. It should not take a lot of time. Okay. It doesn't work, then we'll see why it will throw this error. I know there could be one scenario, but I will check. What do you think? What could be the reason for the failure? I know at least one reason could be there, but I would like you to try it out first. And again, thing is, it is running super slow. It should not take so much time in building. npm run install takes time, by the way. npm install.
The initial error that you're getting because of the kernel, is that because it's for Mac, right?
Yeah, so this, at least this issue, I can fix by this, adding this. For the next one, I think, yeah, we will see. If it goes successfully, then I think, yeah, that trick helped me. I believe this issue should not be coming on Intel processors, but wow, it is running like anything. You know, there is a meme on this. Node modules, because node modules are so large and heavy. And there is a meme on this. Why? Yeah, this one. It failed here. And I know why it could be. One of the reason is that when I was testing this code, I thought this would work, but it seems in node 14 they have removed the support for it. Okay, so we'll have to use the latest node modules. So we'll have to change this code to node 22. So let's use node 22. Okay, and let me see if there is something else which can be going wrong here. So we are using node 22 as build. We have working directory copy JSON. We have gotten this dependency and then install. I think probably that was the reason. Let's give it one more try.
Is that why we were getting all those deprecated warnings?
Oh yeah. Yeah, that could have been the reason. Because this was written like long ago. That used to work long. Then I have updated some part of it. Like for example, if you see in the lab, I did update it to 22, but this one I did not. Ideally, I should have actually. This was just a miss. But anyway, I think they should work. That was probably the reason. But yeah, it is slow. It is super slow. One of the issue could be my internet as well. So, not sure. Yeah, so pretty much I believe you understood the concept which I wanted to show you. This is an example to show you how it works. But apart from that, I believe you are all set. It is slow. I will avoid this library now. I don't know why. If there is an alternative to this is called npm install chromium, but I don't know which one is lightweight. Okay, this is unpack size 23 kbe, and this should be probably higher than. Oh yeah, this is definitely higher size, but they're not that big. Okay, but I believe, do you have any question till this finishes?
So this is standard policy, kind of how you'd see most Docker files written in multi-stages rather than single.
I believe that multi-stage is not a very recent, standard thing. Because multi-stage itself is like a very new concept. It has come almost like 3-4 years ago or something, right? Because Docker itself has come like 10, 8, 9, 10 years ago. So this is not like de facto standard everywhere, but I believe this is becoming. And this is always good practice because you could see the example like size of the image is like getting half of half, sometimes even getting like 20% of the original. So yeah, definitely it is getting. I believe that now on, at least if you know, then I think you should use multi-stage. Okay, I think I have lost hope on this. How much time that one take? That one took last time. Just taking like less time. Come on. Does it take so much time? I have one to-do list application working that I know. That should have nothing to do with this. Okay, guys, I believe for some reason it is just running, but I believe it should be actually finishing because this is how it should work. I can probably find a. I think you can try with this one. This one should also do the job, but I'm not very sure. But this one definitely is recommended by everyone to fix this problem of on Mac. Yeah, it seems that on Alpine you can use Chromium as well, but not sure. Some people have used that, some people have used this, so not sure. Dude. I believe the image that it will should be like 1% of the original image. Then only I will consider improvement because of the time it is taking. Is anyone trying this with me as well? Are you also stuck, or it is because of something else with my system?
I am, and I'm running it a third time with something that may resolve it, but I don't know. So yeah, having the same issue you are.
Okay, I think one of the reasons I feel is that probably maybe my network is slow. The other Zoom is working fine. My network could be slow, so it is installing slowly. That could be one reason, but it cannot be so slow even. Okay, no worries. So that was the lesson, everyone. Once it finishes, I will let you know. Okay. But what I have seen earlier is this. You will see this. This image size, okay, should be like very large. So if you like Docker images, this was like single state, right? You see the size, 1.6 gigs, right? But the next image that you will see here, that will be like 130 MB, almost like 10%, even smaller than 10%. Though here we are using the development environment, that itself is like very large, but otherwise, even if you use not the development environment, still if you serve this application using Nginx, this is what we are doing here. Nginx is very, very small. Okay. So Nginx makes the application very, very small, and it runs very, very lightweight. Okay. So that's the overall takeaway of this application, of this lesson, everyone. Okay. Once it runs, I believe it should give us the same result that we are looking for. Otherwise, we will go ahead and discuss the assignment. If anyone has anything else, let me. Okay, if there are no other questions, then I think probably we will finish the lesson. And once it finishes, then I will let you know. Otherwise, I believe there should be some issue. Otherwise, I don't want to even stop because I'm feeling that, okay, it should finish now. It should finish now. I will lose all the time I spent waiting. So I don't want to even stop it, but I will if this is how it works. Okay? This is how it works. And only thing is, I think we can probably discuss again that it uses Node 22 as build. It will set the working directory, copy the code, install dependencies, then it will use Nginx to serve the application. We will make Nginx daemon off so that Docker will keep supervising that this Nginx is working fine or not. Okay. Oh, this one finished. This is on next step now. uh, yeah, so this one got finished, by the way. I think it's just my system is slow, probably. Yeah, because there are like a lot of things running here. That could be one issue. All right, everyone. I believe we can probably give it to 1 more minute and then we can probably see if it works. Oh, it has done. See, patience is required sometimes. Okay, there's nothing running. I can write docker run. I will give minus minus rm minus p port 3000. I will now copy with port 80. Why? Because we are using Nginx to run serve this application. Okay, and then we will give the image name, and this is React. You can see the Docker has started, and if you open your localhost 3000, your React application is working. Okay, what is the difference? Difference is here. If you say search Docker images, okay, this one is 1.7 gigs. This one is just 194 MB. Okay, you can see such a significant difference. And thank you, Yams. Yes, at one point of time, I had lost my hope. I thought that I'm going to stop it now, but it took a lot of time. It took like how much time? I believe over, yeah, 6. Oh my God, it took 10 minutes. Damn. But no, it was just like my system was slow. Otherwise, it should not take so much time, and you can see the application is working. This is the difference part you can see here that we are using this one. So you should always put the application in production using Nginx only for all the front-end applications. If you are serving any front-end application, if containerized, generally you will not containerize it, but if you containerize it, then you will always put it using Nginx. Okay, what are other ways you can deploy? You can like put this in probably there is a service from Nginx that is called Amplify, AWS Amplify. AWS Amplify can be used. Otherwise, you can use S3 CloudFront. You can use EC2 Nginx. You can use Kubernetes in multiple ways. You can use some other different techniques as well. All right. So yeah, finally, this was the quick example, everyone, that Docker multi-stage is very important to achieve the optimization. Well, so with this, I think we will bring to the end of this session. Okay. If you have any question, let me know. Otherwise, I am here, and yeah, you have 2 assignments. So this is assignment number 1, and assignment number 1 is very similar, but this is like a React clicky game. If you see, this is the React clicky game. So you can go ahead and try and build this image game. I think it is just based on React, so it should work in the same way. Okay. So this is assignment number 1. This is not very important, but assignment number 2 is important. Okay. This is also important, but we have almost done this assignment here. So this is very important, but this is based on Java Spring application. Okay. So we are using Java Spring, okay, to run this application that we have seen earlier. This is our familiar application, okay. And this is not something that we do not know. You enter the details and all, you register an account, and yeah, you get logged in on this beautiful application. Okay. So this is the step. You have to Dockerize this application. You have to create the network and everything. Then you have to Dockerize this application using multi-stage. Then you have to run this. Once you have done this manually, if you want, you can directly go ahead and do the Docker compose. Yeah. How would you do that? I will let you figure it out. Otherwise, we will provide you the help if you want. All right, everyone. If there are no questions, then I think probably the way how we have planned is you can start working on both these assignments. If needed, we can provide you solution of assignment number 2. Okay. And yeah, and then probably in the afternoon, we will raise the assessment number 3. All right, I will chat with Julius once, I will sync up with him, and then yeah, we will, yeah. All right, so your breakout room is open. If you want to go for break, we can go for break almost an hour. And returning break, please start on assignment number 2. Okay, sorry, you can start with assignment number 1 and then 2. Either way, but you have to do, I will recommend both. First one should be easy, we just did. All right, see you. I will go for 10 minutes break and returning then. Yeah, I think I will go for, I will have to exit this so that I will get the recording and then I'll come back. Okay. All right, let me upload the recording, everyone. All right.
Thank you, Chandra.
Yeah.